Hello, developers. Let's start developing. So, for the second part of day 5 of the 2023 Advent of Code, we have quite a different task than the first one. So, in the first one, we had an enumerated number of seeds. Basically, these were the seeds, and we had 20 of them 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Actually, we counted them, there were 20. Now, it seems that we have a different problem. So these are not 20 tasks, but this means that we have 50 million seeds starting from here. We counted them all up and they're about 1.5 billion. And we don't want to loop through 1.5 billion situations. I got corrected on that. It seems that it's not going to take 400 hours. Is gonna take a bit less, but still it's gonna be a long time and it's a lot of work. But anyway, what we can do, we can basically take this range and see what happens to it as we move it along the mapping. Because most of the time, if it fits, for example, here we have mapping interval. So if our initial interval fits inside another mapping interval, that means that it will just get linearly transformed. So if, for example, in this range, so we're starting from 50, we're going to 52. So if we have the first case actually, 7914. That is from 79 all the way up to 92. Yeah. So that means that from 79 to 92, they get transferred. All of them fall into this interval, which means all of them will get transferred to up. Yeah. So it's going to be 81 to 94. And then for the next input, they're 81 to 94, and we don't do anything with them. So they stay on that. And so on and so forth. So we might have some situation when we need to break up intervals, or we will definitely have, because if that's not the case, then it's a very easy task. But let's check it out. So first thing I'm gonna do is I'm gonna go back to the small input and let's see what we have here. We're kind of ignoring the part 1 and let's see what we want to do. First thing that I will do is that I might want to kind of transform the input. So we have all the seeds. I will define a type of interval. Actually, let's have it as an interface. I kind of hate tuples when we have all the elements are of the same type. So if we have a tuple number, it's very easy to get the index wrong. So I will have an interval which has a start and an end. That's a number. And the start and the end will be inclusive. So start belongs to the interval, end belongs to the interval. Okay, so let's transform the seeds into an array of intervals. And it's not gonna be a mapping, it's gonna be some kind of a, oh, it's not an interval, it's an inter. Wow. No, we're not touching the mappers, and we're actually gonna need a for loop starting from 0 all the way to the input dot seeds dot length, and in this specific case it goes up by 2, not by 1. So the start one is the input dot seeds of index, and Then let's just check. So we have 19, 14 values. So the 14th values is not 79 plus 14, but the 19th values is 79 plus 14, which is 93, minus 1. So it's from 79 to 92, which are 14 seats. So we need to have the duration, and that means that this is the interval. Yes, that's cool. We're gonna console log them and return, yeah, the max safe integer. Why not? Let's see. Oh, not this. We need to run the 5th day and see what the second party actually does. It says we are starting at 79, ending at 93. Well, I explained this, but obviously Copilot is not listening to me because we actually need it this way. So from 79 to 92 and from 55 to 67. Yes, those are the correct seeds. So we need now to compare these intervals against the mappers. I think that I would like to remap the mappers as well, but to be honest, I have no idea how I want to do that, but I'll leave that for a while. So that's the destination, that's the source, that's the duration. Actually, let's do this now. Now this works because if I remap them, I would love to remap them into something. Not an interval map, but an offset interval, which actually extends the interval, but also has another value, which is, yep, offset. So, yeah, we can do that. Not for interval to interval, but for each of the, let's deconstruct this immediately. So we have seeds and mappers, and then our code will be a bit cleaner. For each mapper of mappers. So the lingo that I adopted is that we have a collection of mappers, which is an array of mappers, and each mapper is actually a collection of mappings. So for each of the mappers, we need to transform the mappings and this can be a map method. Yes, that thing, well, we need to advance more. So it's destination, source, duration. So how do we transform this? This means that 98, we are starting at 98, we are ending at 99, and the offset that we're gonna do is 48, which is source destination, source minus destination. So we're gonna need to map this into an offset interval, and the offset interval is, so the start of the offset interval is 98, which is the source. I don't need the sign. method, especially not from a crypto library. Then we have the end, which the end in this case is 99, which is source plus duration minus 1. Exactly. And then we have the offset, and the offset is 98 minus 50, which is the destination minus source. This time Copilot managed to do that, and then these are the new mappers, basically. Actually, that's a good name, mapper intervals. Yes, let's have that. That's an array of intervals. So we have the mapper mapping. An interval is a mapping. No, 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 no. An interval is a mapping. Yep. Actually, it's going to be offset interval array of array. So we have the mappers. And then we have our offset intervals. And the offset intervals are actually this. And we have our set of offset intervals. I will put in a breakpoint here. Let's try to run it this way and see what the mapper intervals are actually consist of. I will have the description on the other screen and see if this actually makes some sense. So the first two of the mapper intervals, it's in 2, 3, 4, 2, 3. Yeah, the number is correct. So we are starting with the offset, sorry, at 98, I think at 99, and we have an offset of minus 47. Then we're starting at 50 and going up to 97 with an offset of 2. For another one, we're starting at 0 up to 14, we offset by 39. From 15 to 51 is offset is minus 15. From 52 to 53, the offset is minus 15. Is that so? I'm already seeing something that was not obvious, not really obvious in the input. That the one with 15 and 52 are actually the same thing. Nice. But I see another thing that I would like to have. So I'm gonna have offset intervals to sorted. Yeah, I'm gonna sort them by start. Do we want to run some merging? We might want to merge intervals that have the same, that are consecutive and have the same offset, because that's the same interval. It doesn't matter. So in this case, for 52, we're doing the exact same thing that we're doing for 15. So 15 goes to 0. 50 goes to 35. Yep. And 52 and 53 go to 36 and 30. Yeah, 36 and 37 and 38. And I don't want to do too many calculations, but I guess I'm gonna. Let's see if we have more of those intervals, and then I will see if we have more of those intervals actually in the big input, because that will make sense to actually merge them, because the less intervals we have, the less intervals we will have to process. So we can do some merging here and do some merging here. No merging here possible. No merging. No merging. So I guess that was a freak accident. Anyway, let's see. Maybe that's a good thing. So we have a lot more out. Yeah, we have 40, 25, lots and lots of. And it seems like that was a freak coincidence. But notice, are they sorted? No. One thing with using to sort it is that you actually need to assign it to something. So I wanted to use it like this and I've kind of forgot. Yeah, this makes better sense. Just a sec. Starts from 0. Starts from 0. Starts from 0. I'm gonna write some code to actually do some more investigation of this input. Because now I would like to have a complete set of intervals. So basically that everything from 0 to infinity is done. So I'm gonna do for of mi of mapper intervals, quick analysis. So yeah, if the first doesn't start on 0, I just want to have okay. So all of our intervals start at 0. That's good. I don't think that's the case in the small input. Yep, we have a lot of them that don't start on 0. So what I would like to do, if the first doesn't start on 0, then we're gonna add a new interval that actually starts at 0. So mi.push, not push, but mi.unshift. Yeah, we are adding a virtual interval, so that starts from 0 ends with just before the first actually starts, and the offset is 0. So that is done. We don't need this. So when this executes, we know that the first that the first interval is will always start on 0 and it will always have a defined offset. So, but now we kind of broke this. Ensure that all intervals start at 0. That all mappers. I will do another for of. That will detect holes. Do we have a situation when we have an interval that ends at 50 and the next one starts at 70? So we have an undefined situation between 51 and 69. Let's check that. And for that, we're gonna need a for loop. We're gonna loop through the length of the mi minus 1. We're gonna have the current, which is gonna be mi of index, and we're gonna have the next, which is mi. Yeah, we want to do that, yes, but what we will want to do more is see. Yeah, let's see if we have holes both in the small input and in the large one. Seems that we don't have any holes. That's great. What about the large one? Yeah, we had a hole at the 0 point, but we didn't have holes afterwards. Yep, we have some hole. Yeah, let's analyze them. We're gonna log the current and the next. Let's do it here. Yeah, so you can see that we are actually spending quite a lot of time analyzing the data first, and only after that we will maybe do some programming. So yeah, those definitely look like holes. But there's just not too many of them. So it will be quite easy to plug them in. One more thing, let's see if we have more than one hole. If on whether on a single interval mapper we have more than one hole. No, seems that we have 1, 2, 3, 4, 5, 6 out of the 7, and each of them just has a single hole. The last one does not have holes. That's great, which means that now if we do the splice, generally don't like doing this because we're splicing the array while we are looping it, and that's a recipe for disaster. So that means that we might process something twice, that we might skip an item and things like that, and you have to be very, very careful that you're not messing up the index. But if it's just one time, then it works. If it had two holes on a single mapper, then I would have had to worry about the index. But if it's just one, I know that it will work. So this is not a good solution because if I run it on another input that has two holes in a single mapper, this might break. I have no idea because I'm not gonna test it. So yeah, this says splice right after the current one, that starts after the current ends and that ends before the next one starts with an offset of 0. Yeah, I have a feeling that this will work. However, okay, we did that and now we're gonna check for holes again. So after we try to fill the holes, check it for holes again. If we find the holes on the second pass, that means our code is not running. Now we're just checking for a lot of holes and didn't manage to do anything. That's great. So this actually fills all the holes and I will do just one more loop because I said I want to be complete. So I will just get the last. Not that. And I don't really care what the value is. We're just gonna push another one that starts after the last ends and ends at infinity. Exactly at max safe integer. So anything, if anything happens to go above the last interval, this means that we have the last interval. So what this accomplishes, that number will, any number, any positive number, we're ignoring negatives, any positive number is gonna match exactly to a one mapping. For any mapper, we will have, for any number, we will have exactly one mapping that matches the current number. So let's go back to the small input because we can understand that one, and let's see what we have now in the data. So right now, mapper intervals. So the first one is not 2 anymore, it's 4. So starting from 0 to 49, we have offset 0. From 50 to 97, we have offset 2. And from 98 to 99, we have offset minus 48. And from 100 up to infinity, basically, we have 0. This is the same, only the offsets are given. And again, we have the last offset, which is to infinity and beyond. Well, not beyond. Okay. So now we can do our code actually. And how do we do that and what do we do? We have the mapper intervals, we have the intervals. Actually, these should be seed intervals. That ensures, so this fix any gaps in the mappers and ensure that all of them end in infinity. So now again, we can copy some logic from here. So we're going to have process seed interval. So we're getting a seed. Yeah, we can call this a seed and a mapper and reuse the names. A seed and a mapper. And this will return something. So once more, here we had seeds.map. And here we're going to have intervals, seed intervals dot map process seed interval, that seed interval, and use the mapper intervals instead. Is this not the correct type? Yep. it's not. And this will return something that at the moment we don't know what we want to do. So we have our seeds intervals and we have our mapper and oh, this is interval. So plural. And something along these lines. For each mapper of the mappers, we're gonna run a proceed to process a mapper interval. Something along these lines. So now we have a single seed and a single mapper. And we need to find the next value. So the process mapper took the number and returned the mapping. So this will take an interval and return another interval, let's say. So only it's not gonna be an interval. It's gonna be something more, something worse, to be honest. This is not gonna work because those are not the properties, but what we can do, well, of course, we can say for each mapping of mapper. Only the mapping is an object and it will have the start, the end, and the offset. We might want to use them. It will have other things that we also call start and end, so this is mapping. So for each of the mappings, we want to see, is this seed contained within this mapping? Maybe partially, maybe in any other way. So, how do we know? We know where we start. And at the very beginning, what happens? Yeah, let's think on it a bit. So we have a sequential thing here. So the mapper is actually sequential because we sorted it, which means that until we get to the first, so the seed can be within an interval or it can intersect multiple intervals. Yeah, we're gonna have to do interval intersection, which is never a fun thing, and that's why I tried to make it into a better structure so it will be a bit easier. It will still be a total pain in the behind, but it will be a bit easier. So we will have several cases here. So first of all, we can have if the mapping ends before the seed starts, that means that this mapping is not relevant for that seed. So if the seed starts at 100 and we have a mapping from 0 to 10, we can just continue. Otherwise, if we came here, that means we found the start mapping. We found the first interval that overlaps with the seed. And then what we will do? I will have a result which will be an interval array. So not the seed, we're going to be working with the current, which is a copy of the seed initially. So if the mapping ends before the current starts, we are ignoring them. Otherwise, this means the mapping does not end before our current starts. So that means that there is some overlap and suggests this. So if the mapping starts is bigger than the start of the current, yes, so that means that's not a complete overlap. What options do we have? So we can have the start to be, can we have this? Can the start of the mapping be less than the start of the current? Of course, but can we have it equal and can we have it bigger? No, we're gonna make sure that this is not the case. So the start will be less or equal, which means that we can start our new interval at the current dot start position. Current dot start position is the position where the seed kinda sorta starts. So from that point on until either the seed ends or the mapping ends, we get. So we will find the end. The end is the smaller number of the end of the mapping and the end of the current seed. And no, the start is not that. The start will be always the start of the current. And inside the intervals, inside the result, we will need to push a new interval that starts at current start and ends at end. And additionally, I will set the start point of the current to be over that. One more thing, if we have an invalid interval, we stop the looping because that means that we got into an end. Oh no. The result will be this thing. A tuple of two intervals. Because we will push the part of the interval that we have and we will add another interval here that is actually the same thing, only offset. So this is the actual result that we're looking for. And then we're gonna return the mapped thing. And it's not a seed and a mapper, and it's actually the original and mapped. We need an extra parenthesis, and we're just returning the map. So out of those two, we actually are interested in the second one, and the original is kinda not very interesting for us. So we take a seed and then we return an array of intervals, because this will say that it returns an array of intervals, because we might happen that we break down our interval into two different intervals. And now for each of them, we will need to process. So something like this now. Yeah. Yes. So at the end of this, we can just say result equals new result. So we're starting with an array of seeds and we are ending with an array of seeds, but that array can be split up somewhat. What is the result now? It is an interval array. Let's see what happens. Yeah, we're doing some exploratory running because I wrote some code, but to be honest, I'm not too sure what it does. Right now it breaks because it says something is void. For example, part 2 doesn't actually return a value, and we need to say, okay, return 3. Why 3? Why not? So we have our initial interval from 79 to 92. And we have our first mapping. It says from 0 to 49 offset 0. This is not valid because it doesn't match from 50 to 97. This actually makes sense. So we're gonna end on 92 because 97 is after our end. So we're just gonna, and we're setting the start to 93. Then we have something that starts on 93 and ends on 92. We're done. And now our result will be a set of original. It will be 79 from 92 and mapped from 81 to 94. And we kind of want the mapped. The new result becomes this. So the result is finished. We're gonna go on the next mapper. The next mapper is actually this one, and we have a seed that is from 81 to 94, and this thing that will always, all of it will fall into this. So let's run it once more, and we got the exact same because we have that, and all of it again falls into the last one. So we have the 85, 94, and that should be exactly here. So it should be offset, all of it should be here. We should get a single interval that is offset in that way. So 74 to 87 and 74 to 87. We have an offset of 4 and an offset of 31. So this means that we will have this behavior. Yeah, we're skipping the first one, we're skipping the second one, and we're not skipping the third one. So our seed is from 74 to 87, but the end should be at 76. Yeah, 76. So this means that we're gonna have into a result that from 74 to 76 maps it to 78, 80. And our start, the current seed, is now only the part that's in the other interval, from 77 to 87. Which all of it is in this interval. So on the next interval, again, we're okay. It ends after we start, and we're starting at 77, not as the original seed at 74. We're calculating the end, that's going to be 87, and we're going to push another thing inside our result. We are breaking, and our result now has two things. So basically 74 becomes 78, 75 becomes 79, 76 becomes 80, 77 becomes 45. Okay. Seems to be working. So our new result now has two elements, and after we run it one more time, our new result now is going to have again two elements. Now it has three elements. And now it says it has one element because I think that we start processing the other thing. Great. So when this thing finishes, we're going to have an array of arrays of intervals, which means that our original seed intervals will get broken down somehow, but the result... Oh, we actually need to flat map this. And then we have an interval array. Let's see what we get. Because we're starting with an interval of seeds, and as a result we're getting an array of intervals, and then for each of them, but we're not really have a matrix, we just have an array. So now we're getting these parts out of the initial two, we're ending with 6 different values, and we just need to find out the minimal. And actually, since the end is always bigger than the start, from a visual inspection it looks like the 46 will be the minimum. And let's see here. Yeah, 46. So now we just need to, on this mapped, we just need to return this is interval, and just give me the start, the minimal start. Let's run it actually and see if this gives us 46 as it's supposed to be. Yeah, it does. So the moment of truth, the big input, let's see where we did mess up this time. Note that this might be the first task that actually takes us to part 3. If this is incorrect, but it's a relatively low number, much lower than the previous one. So it has a correct field, but is the right answer. So we have completed day 5. We're waiting for day 6 still. And see you tomorrow. Keep developing. Don't forget to click on those buttons, not the dislike button. You can ignore that, but click on any of the other buttons and good things will happen.